Hey class, here is the Unit 9 test review. For number 1, it says the graph shows parts of a function f. So you can see it looks like a quadratic. It says what is the range, okay? So remember that when it's talking about the range, it's talking about the y-axis. So we look at the range from counting from the y-axis. So it looks like my range is all real numbers going less than 8. Okay, so that's the 8. That's the range right here. So from 8 and then down. So it's not all real numbers, because all real numbers means it's going down and also it's also going up. And B says all real numbers less than or equal to 8. That's exactly what it is. Okay. All real numbers greater than 0, so that would mean something like this. That's for number C, but it's not. And then the last one is all real numbers between -3 and 1. -3 and 1, those numbers are the zeros of a function. But anyway, so yeah, that's the range. Number 2, the graph shows the height of a basketball after it is thrown. Okay, which point on the graph represents the initial height? So here is the vocabulary word for this. Let me go ahead and highlight it for us. Initial height. So initial height is another way to say starting point, so where we're starting to collect our data from. So it looks like the starting point is right here, and it's always going to be at the y-intercept. Okay, the y-intercept is the starting point, the initial height. Okay, right there. So it is not the vertex. So the vertex is right here. This is not definitely the starting point. This is just the where the graph changes direction. The negative x-intercept, well, it does have a negative x-intercept if I keep drawing this down right there, but that's not the one we're looking for. The positive x-intercept is this one. That's not the one I'm looking for. The y-intercept is this one. That's exactly the one I'm looking for. So it is D. Okay. All right. Number 3. It says the function f of x is graphed. So we have the graph of a function right here. What are the values of x if f of x equals 2? Select all that applies. Alright, so when f of x equals 2, it's the same as looking at where your y value is equal to 2. Okay? So if I look on here, my y value is 2 right here, right? It's actually everything on y equals 2 is this line. So we just want to see where does it touch the y axis. So it looks like it touches the y-axis right here. I mean, not the y-axis, y equals 2 line right there and right there. So what numbers are we looking for? We're looking for where your x is equal to 2. So basically we go here and then we drop down to see. So x equals -5 is where your y equals 2, and then x equals -1 is where your y also equals 2. So the answer is -5 and +1. -5 and +1. Okay. Alright, so the table of values represents 2 quadratic functions. I have 2 functions here. I have f of x right here, and then I have g of x right there. Okay. Let me go ahead and put them in Desmos to see if I can see it better, so I can have all these different things I need to look at. So let me go ahead and put the table in Desmos. So in order to do that, we're going to press the plus button, table, and then plug in the table of values. y. So when I graph the first table in here, it looks quadratic, right? It has that shape right there. Let me go ahead and type the next one in. So again, I'm going to press the plus button again, and then I will press the table, and then I'm going to plug these numbers in. -4, -3, -2, and then keep going to 4, and then plug these values in. And we're just going to look at the pattern. It should be quadratic. Well, first of all, because the question says it's quadratic, and also they look quadratic. It has a curve on it. So +1 goes to -2, -3, -6, and -11. All right. So here's the second table. I graphed it, and that also looks quadratic. One is going up, and one is going down. So this one is a positive function, and this one is a negative function. All right. It says the functions have the same range. Well, no, because this range looks like it's all numbers greater than 0, and then this one, it's all numbers less than -2 right there. So they definitely do not have the same range. F of x has 2 zeros. So whenever it's talking about zeros, all it's talking about is the x-intercepts. Okay, so right here, zeros is a vocabulary word. So zeros is the same thing as x-intercept. Where does it cross or touch the x-axis? Not the y, only the x. So if I look on here, there's only 1 0 for f of x. This one says 2 zeros, so that can't be it. And then g of x has no zeros. Well, it's true, g of x does not have any zeros because it doesn't look like it's reaching the x-axis at all. So this one is correct, but it's still not it because f of x doesn't have 2 zeros. It only has 1 0. Answer choice C says f of x has a minimum. Well, if I look on here, it does have a minimum value, and g of x has a maximum value. So minimum value means, so if it's a minimum, then that means that it's going up, so it has a minimum value. If it's a maximum, it's going down, so that it has the highest value. Okay, that's where the maximum is. Okay, anyway, this is true. I don't know why I marked this one as correct. That one was wrong. Okay, and let's just check the last one. The graph has the same, the graphs have the same y-intercept, and that's not true because here the y-intercept is at 1, and this one the y-intercept is at -3. So nope, that's not it either. Okay. All right, so number 5, it says the graph shows 2 quadratic functions. You have f of x. So it looks like the f of x here is on the blue graph, and which most likely represents the g of x. So we're looking for the green graph right here. If you notice, the green graph, it's a little bit skinnier, or it's squeezed in more. So we call this a stretch. Okay. If the graph, was wider than the parent function f of x like this, then we call it a compression. Okay. So just be careful, or just watch closely what's going on in Desmos. So let's go ahead and type the parent function in here. So here's the parent function, f of x equals x squared. F of x equals x squared. So it's this. And then we're looking for the g of x, which is here. And we're looking for something that's stretched up, or it's kind of squeezed in. So f of x equals 1/4 times, sorry, not f of x, g of x. Okay, that happened way too fast for me to check. Look, see how it's wider? I'm looking for something that's inside. I don't know if inside's the right word, but we're looking for something that is stretched in there. So I'm going to take that off. It's not that one. I'm not going to take it off. I'm just going to edit it. F of x plus 4. This plus 4, look, it just moves the graph, the parent function up, which means the minus 3 would probably move it down, which is not what I want. So it has to be answer choice D, but let me show you why. See how it's stretched? The g of x, it's inside and it's stretched up. Vertical stretch. Anyway, it is D. Okay. All right. This question, it says, complete the statement to make it true. The graph of the quadratic function f of x equals ax squared. That's what makes it a quadratic. It's pictured below. So there's different things that each of these letters do to our graph. A, so the number in front of my x squared, the coefficient of x squared, right here, this number, will either make the graph go up. So if A is positive, okay, that means my graph will go up. If the number in front of the x squared is up. Another way to say positive would be A is greater than 0. It doesn't say it in this question, but it's always good to know. Whenever it says A is greater than 0, it's a positive function. That means my graph is going up. When you have A less than 0 or it's negative, okay, my parabola, the graph is going down. Okay? Well, my graph is going down, which means A has to be less than 0, meaning A has to be negative. Okay, so that's this one. The value of C. So C, this number right here, the constant, tells me my y-intercept. Okay, it just tells me my y-intercept. So where is it? Right here. This is the C. Well, if you notice, C is on the numbers above the x-axis, they are positive. So that's positive. So if C was like somewhere down here, then it would be negative. Okay? So that's that. All right, number 7. This one's kind of a tricky one, but I do want to show you how do we want to handle this, number 7. Okay, so here's the thing. There's 3 types of functions that we learned in Algebra 1 so far. We learned about linear functions. Okay, one thing you should know is it has a constant. It's constant, meaning it's not it's going to keep either increasing or it's going to keep decreasing at a constant rate. We also learned about, well, exponentials. Okay. Okay, I spelled that way wrong. Exponential functions. Well, exponential functions, what happens with them is they grow not constantly, but they grow either really fast like this, or they grow really slow like this. So that's why they have a different looking graph. So for constant, it would be a line like that, or they would go down. Okay, and then the third one, eventually, like on this one that we're looking at, are quadratic functions. Okay, quadratic functions, they have it where they're decreasing and then they completely turn around and then start increasing again. Okay, or they start increasing and they turn around and they start decreasing. Okay, so we don't have a graph, and to be honest, I don't want to graph these tables because the numbers are just too off. Like, I don't feel like Desmos will actually help us. So what I want to do is I want to see how the numbers are moving. Okay, so if I look at table number 1, I see that from 2 to 400 we're adding 200, right? And then if I go from here to here, we're adding 300. And then if I go from 700 to 1100, I'm adding 400 to get to the next number. Okay, I'll explain what this means, but I'll leave that alone for now. Another way you can find those numbers is if I start from the last number and then I subtract it from the previous number. See, that's where I got this 400, and then if I do 700 subtract 400, it's just the difference, the 300 and then 200. So that's where I got that from. Okay, if I look at this table right here, it's increasing by 10, so it's 70, it's actually subtracting by 10, so minus 10, 60 minus 10 gives me 50, and then 50 minus 10 gives me 40, and so on. Look, the numbers are constant, right? It keeps changing by the same number all the time. Here it keeps changing, but by different numbers. So I will go ahead and say that this is linear, okay? The question is asking me for quadratic. So linear is easier to find just because it's the same number. Quadratics and exponential, they're kind of more trickier to find. But let me keep going. So this one, the common difference here is 38, right? 40 minus 8 is 32. So it added 32. So for this one, let's see, 200 minus 40 gives me 160. It went up by 160. It jumped up really high, right? So it goes up by 32, and then it goes up by 160, and then this one, it goes up by, what, like 800 minus 200, goes up by 800. Okay, so even though this one has different numbers, this one is going up by different numbers, but this one is not growing as rapidly as this one. So table number 3 is definitely exponential, which means that this is one of my quadratics. Okay. Alright, I'm supposed to find 2 tables, I think. Yeah, find 2 tables. So there's one more quadratic between these two. So I know this is exponential. Look, it's decreasing by what? 900 minus 9,000. That's like decreasing by 8,100. That's okay, as long as the next number is also decreasing by around the same number. But it looks like it is a 90 minus 900 is decreasing by a very different number, 810. Looks the same, but that's a big difference. And then this one is 80 minus 81. So this is also exponential, which means that table number 4 must be my quadratic, but let's check. So it's decreasing by 100. This one is decreasing by 200. This one decreased by 300. Okay, well that's also quadratic. Okay, so that's the answer for that one. All right, number 8. If f of 2 is equal to 14, which would be the equation for f of x? So all this question is asking you to do is plug 2. So this is your x value, and then which one will give me a y value of 14. So let's see what f of 2 is. So I'll show you how to do this much faster in Desmos. So I'm going to go ahead and plug in my f of x just the way it is. So you could either go in and change the x to 2 and see what it's equivalent to. It doesn't work like that, does it? Okay, hold on. So let me just take this off. So that equals 22. I'm looking for 14, so that didn't work. But let me show you another way to do this. So you have this. If you just go ahead and plug in f of 2, Desmos will actually plug it in for you and then get you your answer. That's a 22. That didn't work. Let me try again. Let me try the second one. F of x squared plus 3x plus 4. And then you have f of 2 is 14. There it is. So here for this one, f of 2 was 22. Here, f of 2 gave me 14. It's just the way you would have to like plug things in Desmos. If I plug 2 in here, so let's say that's 2 squared is 4, 4 times 2 is 8, 8 plus 3 is 11. So that gives me 11, and then this one also doesn't give me something. It gives me something else. Anyway, it is B. All right, a couple more questions. Wait, am I missing number 9 on this page? Oh yes, right here. All right, Tina needed to factor a polynomial, so she graphed it on her calculator. What did Tina write as a factored form? Okay, so there's, like, honestly, to be the easiest way to do it is to remember that this is a factor, but when I'm writing it in factored form, I have to take the opposite number. So x, if it's -3, you'd have to take positive, and if it's +2, you'd have to take negative. So that's the easiest way to do it. But if you can't remember the way that works, you can always just graph each one and then check. I'm going to go ahead and graph the first one. That looks right, but look, if you look closely, it's not. This is at, well, I don't know why it's not clicking on here. My clicker stopped working. Anyway, that's at 2, and then this one is at 3, but I'm here, I have a -3 and +2. Okay, so there's -2 and then +3. Oh, by the way, I'm using the wrong Desmos. Let me pull up the right Desmos. Desmos testing and make sure, oh, not the College Board one, I want the Desmos Virginia High School. Okay, so that is it. C, answer choice C. Alright, now number 10. So the next two are quadratic regressions. So for number 10, I'm going to go ahead and plug the table in. .4, make sure all of the numbers match. Okay, so there are my numbers. Okay, it kind of does a weird shape, but still it has a good quadratic form in it. And then we have to make sure to type the regression, which is we have to type y1 regressed against ax1 squared plus bx1 plus c. Okay, so I'm going to go ahead and type it up. So you have y1 regressed against ax1 squared plus bx1 plus c. And then here we go. So a is 0.11, and looks like it's rounded up to 0.12 right there, 2.11, and then 4.22. Yeah, those are just rounded, so there's my answer. That's my equation. Here's the next one. So I'm just going to type it in. And type all the other numbers in. One thing I do want to remind you is when you're doing tables and you see a comma, like for example right here, do not put the comma. That doesn't work. Okay, it's going to give you an error. So just type just the numbers in. Okay, and then type the regression, y1 regressed against ax1 squared plus bx1 plus c. And then here's my equation. So looks like my equation is going to be y equals 1.21 x, oh, it says 3 decimal places, okay. So that means I'm going to go ahead and take 3 numbers right here, 1.29, 209 x squared plus 12.998, but the 8 will have to go up because of the 6. 6 is higher than 5, so that's 12.999x plus c is 504. Oh, it already has 3 numbers, so I'll just leave it like that. So that's the equation. So the word model just means equation. Using this equation, what will be the estimated population at 2020? Okay, so look at how it's asking for when x is 20 in 2020, but look at how the table works. The table is x years since 1970. So if it's 0 years since 1970, so this one 0 would represent 1970. So plus 10 years would be 1980, plus 20 years would be 1990, plus 30 would be 2000, and then that'd be 2010. Okay? So if I'm looking for 2020, I'm looking for actually when x is equal to 50. Okay? I cannot just put it in the table right here because it's not going to be any helpful to me. I have to take my equation and I have to go ahead and plug in 50 right there because that's what I'm looking for. Okay? That's the number we're looking for. So for 50 squared plus 12,999, 50 again, and then plus C, which is 504 plus 257. Okay, so you can calculate that in decimals. So 209, plug in 50 plus 12.999, 50 plus 504 plus 257. There you go. So in 2022, oh wait, 2020, not 2022, 2020, it will be, population will be at 4,170, still rounded up to 77. Okay? Alright, well, that's part 1 of our assessment. Thanks for watching.